So now that we have learned how to multiply fractions and we've done a bit of practicing on that, we understand how that now works, we're going to move on and look at how we can divide fractions. So today's lesson will involve you still using your knowledge of multiplying fractions to help you learn to do this new rule for dividing fractions. So as I've said before, fractions is a very important topic. It's used in lots of different careers. You can see some of them on the screen. So it's got lots of practical applications. You're using your thinking skills again today. Make sure you're organised with your work as we do this. So what we need to think about first is, if I said to you, what's the answer to 8 divided by 2? There's a couple of ways of thinking about that. You could think that means I've got 8 coins that I'm going to share between 2 people, or you could say how many groups of 2 can I make out of 8. So if I was saying how many groups of 2, 8 divided up into groups of 2, right, hopefully visually, right, you know the answer, and I expect you know the answer, right, to that is 2. But what if instead we were doing 8 divided by a half? So what would the answer be here? So what we need to think about to help you understand what the answer to this is going to be is, if we think about, imagine these wee yellow circles here represent 8 cakes, how many halves can I make out of 8? Right, that's really what we're thinking about here. So if I split all these little cakes into halves, and we said how many halves are there? Hopefully you can actually see that there are 16. Now, as you know, 16, the connection between 8 and 16 is that 8 times 2 is the same thing as that answer. So actually 8 divided by a half is literally just the same thing as saying, well, actually what I'm doing is 8 times 2. And we saw in our multiplying that the 2, right, any whole number, right, can be written over 1. Then what I want you to look at is the fact that I'm now saying I was trying to do this original calculation, 8 divided by a half, and what I'm saying is that is the same thing as doing actually 8, rather than dividing, I've actually timesed, and then not multiplied by a half, but I've multiplied by what's called the inverse of this number at the end here, the half. It has flipped over and it's become 2. So we're going to use this idea to get our rules for dividing fractions. I'm going to call these rules keep, switch, flip. This will help us as we progress with our work on dividing fractions. So looking again at this example here, you might want to copy this out into your jotter, so you can pause the video if you do. So 8 divided by a half, I've said keep the first number, so I've rewritten it down again, so I've written the 8 down again. The switch bit is that if we change the divide sign to a times, and then flip is flip the last term over, so that half has become 2 over 1. Now it doesn't quite look like our fraction multiplication yet, but as we know, the whole number 8 can be written as 8 over 1. Once we've done that, we've then got, there's no cancelling to do here, so we're just doing 8 times 2 on the top, 1 times 1 on the bottom, so 16 over 1, but we know that that would give us the answer of 16. So just to recap on that, this keep switch, flip is the method that we're going to use to help us do dividing by fractions. So we could do the same thing with this example here. So if you'd like to have a go before I write down the answer or talk you through it, then again pause the video and then you can check your answer. So using this keep, switch, flip, what's the answer to 6 divided by a third? So I keep the 6, I switch the divide to a times, and I flip the second fraction over. So as we know, I should say to you to make it fraction multiplication, we write that 6 as 6 over 1 times by 3 over 1. That's going to give us 18 over 1, and as we know, the answer to that is simply 18. Okay, another way, if you were thinking about that, if you had 6 pizzas, how many, and you divided each of your pizzas into 3 bits so that you had lots of thirds going on there, 6, all 6 of them divided up into thirds, you would have 18 pieces if you did that. So with whole numbers it can be relatively straightforward to see what the answer might be when you're doing a whole number divided by a fraction. You can do that visually, however it's a wee bit harder to do this where it's a fraction divided by a fraction. But again, if we stick to our keep, switch, flip, we will get there with our answer. So keep if we're trying to do 2/3 divided by a half, what we would do is we would keep the 2/3. We switch from the divide sign to the times, and we flip the second fraction over. So we end up with this calculation here, trying to do 2/3 times 2 over 1, and there is no cancelling to do, so I'm going to go straight to 2 times 2 is 4, 3 times 1 on the bottom there is 4/3. We should really change that back into mixed numbers, so remember that means that I would be doing this, bottom number into top number, so 3 over 4, right, that's going to give me 1, and then I'm going to have a remainder, I've got a bit left over, which would be 1. So when I write down my answer, the 1 on the top there, that's my number of whole pieces, and the remainder is how many thirds I've got left over. If I have 4/3, right, I can make 1 whole piece and 1 bit left over. So that's still using our knowledge of mixed numbers and improper fractions as well. So here's 2 for you to try. Again, pause the video and then you can check your answers as I've got them written down. So for example 3, right, using the keep, switch, flip rule, so we would keep the first fraction, so 9 over 4. We would switch, that middle sign becomes a times, and we flip the second fraction over. So here, right, we should be looking to see, can I do any cancelling? Are there any numbers on the top of the fractions that are in the same times table as any of the numbers on the bottom? And hopefully you can see that 2 and 4 are there, so we can make it a bit simpler by saying I can divide 2 into 2 goes 1, 2 into 4 goes 2. And then what I'm able to do after that, right, 9 times 1 would give me 9, and on the bottom 2 times 7 would be 14. So if you paused to do that one, check your answer. For this last example that we're going to look at, if you do the keep, so 4 over 9, switch, change the divide to times, and flip the 15 over 8. So again, looking to see if you can do any cancelling. Hopefully you spotted that you could cancel between the 4 and the 8. So 4 would go into 4 ones, 4 into 8 would go 2. That's not the only cancelling we can do though. The 9 and the 15, they are both in the 3 times table. So we can say 3 into 9 is 3, 3 into 15 is 5. That then leaves us with doing our calculation now. So we're doing 1 times 5 would be 5 on the top, and 3 times 2 would be 6 on the bottom. Always make sure that your final answer, if you don't do the cancelling bit, make sure that your final answer is in its simplest form. So if you, for example, right, with that last one, if instead you did this 4 over 9 divided by 8 over 15, and then wrote and said I've got 4 over 9, kept the first fraction, times, and then flipped, and then did 4 times 15 on the top there, you'd get 60, and 9 times 8 on the bottom, 72. You're then trying to get from 60 down to 72 by keeping on simplifying. You may or may not spot that, well, that they're both in the 12 times table. So if you divided by 12 top and bottom, you would get the answer of 5 over 6, which was the same as we got before, but it's not necessarily easy to spot that you can divide by 12. Of course, you could do that in stages. You might divide by 2, but you'd have to do it a few times. So the advantage of simplifying at this stage here, where you're looking for the pairs where the numbers are a bit lower, it avoids that having to, one, multiply with bigger numbers, and also then trying to simplify. So you're now going to practice this work.